Hello everyone, we're going to be covering section 7.2 out of your books, division properties of exponents. Before we start, I want to recap everything you should know about exponents and the operations, but also talk about this term called monomial. Monomial is a number, a variable, or the product of numbers and variables. So 5 is a monomial, 11 is a monomial, any number. X is a monomial. The product of them, so 5x is a monomial. Do you think 5x to the second is? Well, everything's being multiplied, so yes, it is a monomial. And we're going to be using monomials today to go through all the exponent rules. There's 4 operations covered in section 7.1 and 7.2. First one was adding, which we've already gone over. Multiplying exponents, raising a power to a power, and dividing exponents. These are the new ones, number 3 and number 4. We're going to divide, which is really subtracting, simplifying or canceling exponents, people have called it. And then number 4 is flip. The last thing is when you have a negative exponent, it drops the negative. What about 0 as an exponent? We will also mention that. That is in here too. And we also have objective. Students will be able to simplify using division of exponents within examples using all 4 of the exponent / monomial operations. So let's talk. I just do want to mention anything raised to the 0 is the easiest thing. So that's 1. So x to the 0 is 1. 5 to the 0 is 1. W, even variables to 0, always equals 1. And let's show you some examples. We're going to go through all 4 of these now really quick. So we did the first rule, which was x to the 7th, x to the 2nd. So dividing has the same idea as multiplying, but we're going to explain to you quickly what this means. The same base, you add them. Same base raised to a power, you add them. You can also write them in expanded form, which we're going to do for the next one, which is 3. So the third topic, which is dividing exponents, is when you have 2 powers with the same base, you subtract the exponent. So we have w to the 7th and w to the 2nd. Which one's bigger, the numerator or the denominator? The numerator is bigger, so we're going to say that the answer is subtracting the exponent, so 7 minus 2. And whoever was the bigger of the two gets the leftover. So w to the 5th. Well, what happens to the w to the 1st? Second, it goes away and you just put it over 1, or you can just write the answer as w to the 5th. What does that really mean? It means if we write it out in expanded form, we have w times w times w times w times w times w in the numerator, and w times w in the denominator. And the rules of simplifying or reducing, you cancel these out and replace them with ones. So the final answer is what is left. And what is left is w times w times w times w, w to the 5th in the numerator. All right, now we're going to begin going over examples. So these are going to be ones you're going to be able to try. We're going to make an Edpuzzle of this, and you can check your answers as you go. For the first example, now we have we have a bigger monomial on top and a bigger monomial on the bottom. Let's simplify it. So example 3b, g to the 3rd, h to the 5th over g to the 1st, h to the 2nd. Which one's bigger, g to the 3rd or g to the 1st? G to the 3rd. So when you subtract, the answer is whatever is left over is going to end up going in the top. Ooh. So the top is going to end up being, so you have to now decide, does g go on the top or the bottom when you subtract g minus 1? Notice I wrote in g minus 1, every single variable, exponent, anything. I'm even going to do it over here. Anything that doesn't have a variable, an exponent, you can write in a 1, and you should. So even the 7 has a 1. The g didn't have a 1, I wrote it in, g to the 3rd. We're going to go over this, g to the 3rd over g to the 1st is g to the 2nd. And h to the 5th over h to the 2nd is going to be h to the 3rd. Now, does that go on the top or the bottom? We'll write it here as best we can. All right, let's move on to the next one. Now, over here on this example, it's 3 to the 1st, p to the 5th, 7 to the 1st times p to the 2nd. order of operations state. Before we can take this 2 and share them, before we just start doing this and go, oh, he goes here, he goes with him, he goes with the, we raise a power to a power all over the place to all 4 terms. Before we do that, we have to ask ourselves, is there anything inside of this parentheses, p parentheses for order of operations that you can simplify? And that would be the p to the 5th over p to the 2nd. So you would right away start simplifying that one. So what will we first do with this 3? So the 3 as an exponent of 1, does the 3 become 3, or does it become 3 to the 2nd? And as we go through, these are the steps. It does become 3 to the 2nd. You shared the 2, also goes with the 3, making 3 to the 2nd. What about p? What does p become? P becomes p to the 6th. And what happens to the 7? Does the 7 also have to be raised to a power? Yes. So the final answer is going to be 9p to the 6th over 49. What about 0? So here's the rule for 0. See this big thing? Raised to the power 0? Everything gets a 0. So 2 times 0 is 0. 4 to the 1st times 0. Everything becomes 0. It equals 1. Everything you ever can imagine raised to the power. 7 to the 0, 1. W to the 0, that's a 0. 1, it's always 1. Next, the final one, the final rule is going to be the flipping and negative exponent rule. So when do you flip? So negative exponents mean you flip. When it's in the top and the numerator has a negative exponent, you put it in the bottom and drop the negative. When it's in the bottom, the negative is in the bottom, like down here, you flip the term to the top and drop the negative. So you always try to do this one first when you can. Obviously, you following order of operations is also the most important, but you want to try to do this one before you do any distributed. Anytime you have a power raised to a power, you want to do this operation first. So let's look at it. So the very first example here is it's going to say simplify x to the negative 7. Well, that really equals x to the negative 7 over 1. We never write over 1, but that's what it means. So when we go to flip it, the answer is going to be x to the 7 is now positive because we put it in from the numerator, we put it to the denominator. So we are done. Let's look at this one. Again, 3, I always write the exponent in. That's 3 over x to the negative. So when you go to solve, you have to ask yourself, 3, is that a positive exponent or negative? Well, it has a positive 1, so you leave it alone. You leave it in the top. A to the negative 8 is negative. Do you leave it in the bottom or put it in the top? You obviously put it in the top, leaving you with 3a to the 8th. So let's talk about this one. The first one, we're going to go through one term at a time, and I'm going to ask you what the answer is. N to the negative 5. Do we leave it in the top, or do we put it into the from the numerator? Do we put it into the denominator? So this one goes to the denominator. All right, I did the first one. But now, do you leave the p to the positive 4? Do we leave it in the top, or is it negative? Do we have to put it in the bottom? And the answer is it's positive. We leave it alone. We put it into the top. And then r to the negative 4, do we leave it in the denominator or do we put it up to the numerator? So final answer, let's take a look. The final answer is p to the 4th, r to the 2nd, all over n to the 5th. So let's go back to the second example we have here. So the second example is 5r to the negative 3 t to the 4th over negative 20 r to the 2nd t to the 7th times u to the negative 5. So let's go one term at a time. 5 over negative 20. Well, those can be reduced, leaving you with 1 on top, negative 4 on the bottom. How many r's are there going to be? We have 3 on top and 2 on the bottom. Do the 3 on the top stay, or do they go to the bottom and become positive? They become positive. So, but there's already 2 down there. So altogether, we're going to have how many r's on the bottom? It's r to the 5th. So that's going to be r to the 5th. And we have to do the same with the t's. How many t's are there going to be? There's no negative, so we just simplify it. And then we flip the u. So that's a negative, so the answer is negative u to the 5th over 4r to the 5th. T to the 3rd.